Hello everyone in my channel. This tutorial is for the second method to calculate tail and index using the package read regional economic analysis toolbox. In the second method I'm using second method to calculate tail index. So follow my steps. I will start first by introduce the package. This package that I'm using. To use the package, you need to install it using the directory or cron. So go to packages, choose install and choose package archives. You will find this package down in the description, and so choose the package, open it and click on install. The problem that this package was already in the repository cron, and the error has they deleted this package because the author didn't correct some errors. So this is the package that I'm using, regional economic analysis toolbox. This for the author Thomas Wieland. I think this author is a German. Description: collection of models and analysis method using a regional and urban economics, economic geography, measure of inequality, regional disparities and convergence, regional specialization, as well as accessibility and spatial interaction models. So in this package you will find a lot of coefficients to calculate. For example, we have here the Atkinson index for the inequality with respect to regional income. So you'll find also the beta convergence for the nonlinear square for non-linear least square method or technique, and the beta conversion for the ordinary least squares. La méthode du moindre carré ordinaire. And also we'll find the coefficient of variation for the standardized and non-standardized version, and the weighted and non-weighted version. And also you will find the Gini coefficient, calculating the Gini coefficient of inequality, standardized and non-standardized, and optionally plotting the Lorenz curve. There is also Gini concentration and growth. If you want to calculate growth rates, this function calculates the growth from two input numeric vectors, and also the Hansen accessibility for given origin and destinations. Also Hoover concentration with respect to regional income, GDP for example, and the population, and also the Krugman concentration. Krugman concentration coefficient for the spatial concentration of the two industries based on regional industry data. There is also the sigma. Where is the sigma this is the sigma concentration or the sigma convergence for the researcher that work in the economic geography. So there is also the Williamson coefficient. The Williamson coefficient is also the same. is the coefficient of variation. It's the same index. So we will move now to our object is to calculate the tail index of the inequality. This is the function, the tail function. We have x is a numeric vector weighting, so we will explain all this part. So now I will move to my data. The second package that I'm using is ggplot2. This package helps you to plot all kinds of graphs and very nice graphs with a lot of tools and options. The third package is the read Excel because my data is in an Excel file, so I will need this package. As you see my data, I have 12 regions. As you see, this is my variable is the GDP per capita, regional GDP per capita from 2001-2015 for 12 region. It's GDP, and in this part you will find the number of population from only 2004 and 2015. Why we will need this number of population? As I said in the video, I will calculate two versions of this index, the weighted and weighted. For the weighted version, we will need the number of population of each region. So that's the goal of introducing the number of population. So I will leave all this data down in the description to can run the simulation for this tutorial. I should also, this author has a paper explaining and introducing the package. This is the paper. I will leave it also down in the description. It's a regional economic analysis toolbox for R by Thomas Theil. I hope I am pronouncing the name of the author correctly. Sorry if I don't. I think it's a German name. This paper introduces methods of regional economic analysis are widely used in regional and urban economics as well as in economic geography. This paper introduced the rate package for the programming environment R, of course, which provides a collection of mathematical regional analysis methods in user-friendly way. The focus is on the identification of regional inequality, beta and sigma convergence, measurement of agglomeration, point-based measures of clustering and accessibility, as well as regional growth. The theoretical basics of the application are briefly introduced, while the usage of the most important function is set and explain the using real data. So we will need to dig on the theoretical foundation of this, for example, beta and sigma convergence and the agglomeration concepts. So we will move now to the application. I forget to show you this. As you see, let me see. This is the table containing all the coefficient and indexes that we have mentioned. As you see here in the tail index, in the weighted, you see that we introduced the number of population of each region, WI, meaning the number of population of each region. So I will leave all this paper down in the description too. Moving now to calculate our index. So we will start always by loading the data into R. So to load the data, go to manually, of course, go to import datasets and choose the Excel form. If you have other forms, just choose, for example, Stata or SPSS. Show and browse to your data. This is my data. This is my data. I have already loaded the data, so no need. This is the loading data manually, of course. To see this data, just run this code view. Sorry. Now it will work. So to view the data, it's the same data of Excel. This part containing the regional GDP per capita from 2004 to 2015, and this is the number of population only from 2004 to 2015. So I will start first by as you see, this code is quite different from the first method. In this method, we will apply the function directly for the whole years from 2004 to 2015. There's no need to calculate the tail index for each variable, and after that we gather the result in one variable. So no need to this. So we will apply this function. We will use apply implemented in R. What I'm applying this function called tail of the package read. This package, I'm applying this function. The function is called tail. Applying for what? Applying for this data from 5 to 16. Where is 5? So 1, 2, 3, 4, 5. This is 5, column 5. So I'm calculating tail index from 2004, the column 5, to 2015, the column 16. The column 16 is year 2015. My data called PIB, le PIB intérieur brut, from column 5 to column 16. What I'm applying the function tail. So run. This is the results. As you see, the results here is in the panel environment. If you want to see the results, just click or type view and run the code. This is the results from 2004 to 2015. See, this is the result. It's the same result of the first method. If you remember with me that we have found in the tail index 2004, the result 0.0166. So moving now I will create a sequence of years when I want to implement, when I want to plot the graph, I will need the function years to see the evolution of the tail in function of years. So now I'm creating the sequence of years. So I have the sequence from 2004 to 2015. So run the code now. You see in the environment, this is my sequence of days. Now we will create a data frame containing the results of the tail unwanted index and the years and the sequence of years. The data called tail y. Click now, run. Here is my data above here. Now I want to see the evolution of this index. So I want to plot this result to see the evolution of the unwanted tail index. Run. The data is called tail y. X we have the years, the y we have the whale unweighted. Color I choose red. You can choose any color if you want. This is the title, l'évolution de l'indice de T de 2004 jusqu'à 2015. The title is in French language. Pour la version non pondérée. La version pondérée, on n'a pas introduit le nombre de population. So, as you see, here's the evolution tail index. If you want to interpret this, the evolution, you will need to dig on the policy make the policy or the economic policy and for each country, and to see how this policy has impacted the distribution of the GDP. For example, we have here the impact of the economic crisis in 2008. We have a peak. It means that the inequality has risen. So no need to. The interpretation is correlated to each data set and each country, and so we will pass this thing. So now we will move to calculate the weighted version, la version pondérée de l'indice. So the weighted version, we will need the number of population of each region. So this section, and also this section, of course, the GDP, the regional GDP per capita. So applying this function. Say I have already explained this part. So the first variable is the GDP per capita from column 5 to column 16. And the weighted from column 21 to column 32. This is the column 21 is year 2004, and column 32 is in the 2015 population number. So now we will run this code. This is the result in the panel from 2015 weighted version. So as always, I will create a sequence of years to help me to plot the graph from 2004 to 2015 by year. Data frame called while, tail while, the variable. The data frame contains the variable that I have already calculated and years 2000 from 2004 to 2015. Now I want to plot this data. So using this code ggplot, the data called y, and the x you will find years, and y you will find the results of the variable tail. This is the hex code of color. If you want this color, just go to Google and type hex code color. And this is the title, l'évolution de l'indice de Theil régional de 2004 jusqu'à 2015, la version pondérée. Now I will run the code to see the results. As you see the result, it's the same as the method 1. It's quite different from the version unweighted. Moving now to save data in Excel file. Before that, I will create a sequence of years from 2004 to 2015 and saving all these results in one Excel file. So I will create a sequence of years so that data frame called B containing the unweighted version and the weighted version, and also the years that I have created. And I will call this data B. Sorry, I should run this first. Now you see data frame. If you want to see the data frame, just go to the directory where are you working. This is the function open, implemented in read Excel package. The data frame is B and the title Theil version 2 from 2004 to 2015. This is the results. I save the results in Excel file. So if you want to do kind of comparing analysis between the weighted and unweighted version, what I have did in this code that I have gathered or have englobed the two versions, the weighted and unweighted, in the same graph and the same plot to see and to compare the evolution of the two variables. So I will run this code. As you see, the two versions in the same graph. L'évolution de l'indice de Theil régional, les deux versions, l'indice pondéré et la version non pondérée. As you see, the blue color is more plotted because we have some negative values. So, and generally this is method 2 to calculate tail and x. It's the same as the first method, but in the second method is more quite easily to apply and using this apply function. If you are using the second method, you need to take attention to the columns, number of each column that will impact your results. So you will be attention to the number of columns. Number this in red. You should verify the number, because that will impact your results, of course. And you have the choice to choose between these two methods. So I will leave this code and the results and the papers down in the description if you want to download it. And you can re-simulate this tutorial on your laptop. So I should mention that you need to import data manually, because you don't have the same user. For example, if you are using Mac, this path will change, so I advise you to import data manually. Go to the import section and choose, for example, Excel file. Do this manually. I will leave these two papers, the guide of the package and this paper. A regional economic analysis toolbox for air. It's a very good package compared to other package that's used to calculate all the regional inequality coefficients. For example, we have here the specialization. It's a very good paper. You will find also down in the description this result and the code, of course, that I'm using. The Theil index method 2, results, and the data. This code, you can generate this code for your own data sets. If you have any question or anything, just type it down in the description. And if you like my video, just hit like and subscribe. That's which will encourage me to publish more videos, educational, of course, using R and other software if needed.